Hello, today we will discuss the reflection and refractions in optical fibers. As we know that mirror reflects the lights, if you have the plates like the mirror and the light incident on the mirror, then transparent medium reflected the lights over the glass. Let us see the laws of reflections and refractions. We have the materials boundaries, okay, and let the incident ray have the angles phi ones with the material boundary, and n1 is the refractions of the medium one, and n2 is the reflections of the materials 2, and here the n1 is greater than n2. So the incident rays make the angle phi ones with the material's boundaries. Now, if you see the diagram, the some wave is refracted with the angle phi 2 with the normal line and theta 2 with the material's boundary. Same the way, some fractions of the light is reflected with make angles theta ones. So reflection law says the angle of incidence is equal to the angle of reflections, and by the Snell's law of refraction, n1 sine phi 1 is equal to n2 sine phi 2. Okay. Now the phase shift due to total internal reflections, we can find this the formula. The totally reflected wave experiences a phase shift over, which is given by 10 del n by 2 is equal to under root n square cos square theta 1 minus 1 upon n sin theta 1 comma the 10 del p by 2 is equal to n under root n square cos square theta 1 minus 1 upon sin theta 1. Here n is equal to n1 upon n2, where Pn refer to the electric field components parallel or normal to the plane of incidence respectively. Which angle is larger? A light ray is emerging from glass to air. Which angle is larger in glass or in air? So if you see the normals, and this is the yellow line shows the glass, and this is the angle of the incidence, and the medium is air. So if you calculate the angle, let us suppose light rays to emerging from glass to air. Okay, so we first find out the critical angle for a glass air interface. The angle of refraction in the air is greater than incidence angle. So let us suppose this is a incidence angles, and this is a partial reflections, and this is a incident angle, and the blue line show the angle of reflections. So which angle first? If the angle of incidence increases, which angle will reach 90 degree first, the angle of incident or the angle of refractions? So A, angle of incident from glass, B, angle of refraction in the air. When we increase the angle of incident I, the angle of refraction R increases until when the angle of refraction is 90 degree, the incident angle is called a critical angle C. This is the critical angle C shown in the diagrams. It has the 90 degree with the air. Okay. For glass air interface, the critical angle is 42 degree. At critical angle, the angle of refractions is 90 degrees. So by the laws of refractions, n is equal to sin r upon sin I, that is equal to 1 upon sin c. N sin c is equal to 1, sin c is equal to 1 upon n. And for glass, the refractive index is 1.5. So C is equal to sine inverse 1 divided by 1.5. Critical angle is 40 degree. For water, the refractive index is 1.33. C is equal to sine inverse 1 upon 1.33. So critical angle is calculated at 48.8 degree. So critical angle C is equal to sine inverse 1 upon n. What if the angle of incidence from glass is larger than the critical angle? The angle of refraction will become smaller again. There will be no reflected ray. The light ray will be reflected the same way back. Total internal reflections: when the light ray from water is emerging at the critical angle, the reflected ray will be along the interface. This is the air, this is the water. When the incident angle is larger than the critical angle, total internal reflection will occur at the interface. Let us say this is air, waters, and this shows view under waters. What happens? This is the air, this is the waters. So total internal reflections occurs in this way. Fish eye view. If you see the fish eye view waves, total internal reflections here, total internal reflections here again. Thank you.